Distinguished guests, ladies and gentlemen, and media friends, good morning. Welcome to the AI Next Forum 2025. I am Jill, your moderator today. The COMPUTEX preview video we just watched shows that this year's exhibition will be held from May 20th to 23rd for 4 days at Nangang Exhibition Center Hall 1 and Hall 2. COMPUTEX is ready. We look forward to welcoming partners from around the world to visit, exchange ideas, and create new business opportunities together. It's a great honor to join you today at this international forum focusing on AI computing. This morning's session will explore key turning points and opportunities in the AI ecosystem, with global industry leaders sharing how open deployment, cloud computing, and AI computing power are reshaping industries and helping businesses seize transformative opportunities. Before we begin, I would like to introduce the distinguished guests joining us today. Please wave when your name is mentioned. First, Mr. Peng, Chairman of TCA. Thank you, Chairman Peng. Next, Mr. Chuang, VP and General Manager of Asia Pacific and Japan at Intel. Next, Mr. Robert Wang, Managing Director of AWS Taiwan and Hong Kong. Welcome, Mr. Wang. Next, Ms. Emily Hong, Chair and CSO of Wang Corporation. Next, Ms. Denise Lee, Partner at McKinsey. Welcome, Ms. Lee. Thank you. We are honored to have representatives from various countries' economic and trade offices in Taiwan joining us today. Allow me to introduce some of them. And when I call your name, please kindly wave to our participants. First, Mr. Fernando Mario Schmitz Hernandez, Director of the Chilean Trade Office Taipei. Welcome. Next, Ms. Aznifa Ghani, representative of the Malaysian Friendship and Trade Center. Welcome. We are also honored to welcome special guests from the state of Arizona in the United States, joining us for the forum today. First, Ms. Sandra Watson, President and CEO of Arizona Commerce Authority. Welcome, Ms. Watson. Next, Mr. Ian Steff, CEO of My Silicon Campus and former Assistant Secretary of the U.S. Department of Commerce. Welcome, Mr. Steff. We are truly happy to have such distinguished guests with us today. Thank you so much for your commitment and dedication to our ICT industry. Next, allow me to welcome the chairman of our organizer today, the chairman of TCA, Mr. Paul Shuanglang Peng, to share a few words. Distinguished guests, esteemed speakers, ladies and gentlemen, and fellow colleagues, good morning. I'm very honored to represent the organizer of COMPUTEX, TCA, to participate in the first forum of COMPUTEX 2025. Our forum is AI Next. This is not only a beginning point for deeper dialogue for our industry, it also is a preview of how edge computing and AI application will bring new business opportunities and transformation for various industries. COMPUTEX is now a key milestone for our technology industry here in Taiwan. It also witnessed technological growth in Taiwan, not just in semiconductor. This year, we focus on AI computing, communications, cybersecurity, semiconductor, and green energy. It is a great platform for us to explore next generation application. This year, we have invited many experts from hardware to a software solution to display all innovation and potential of AI application. The AI is now moving from cloud to edge. It is accelerating its change, the change that it brought to our life. Taiwan boasts a comprehensive manufacturing capability for both the software and different components of AI. We now deploying AI in many different areas, from medical industry to sports industry and so on. There are two key points for the forum today. One, we gathered around a lot of important suppliers in our COMPUTEX today, including NVIDIA, AMD, XK, Helix, and Electron and Micron, and so on. Together, they will showcase their most innovative products in the COMPUTEX. Also, our Risk V venue will host the Risk V Risk 5 AI Day, and it would showcase a lot of key topics. And also in our Innovex exhibition, you will be able to see great dynamics, including the AI pavilion by the US AIC, and also by our National Institute. In our official award, half of the awards were given to AI relevant products. This shows that AI is now a key driver for many areas of industry growth. And the second key point for the COMPUTEX today is how its application has been expanded. We now have the drone area, the humanoid area. AWS and Solomon will showcase how Gen AI and Agent AI agent can lead the technology of robotics. And also the AI applications, smart communication, smart transportation pavilion will also showcase key AI application in transportation. I want to thank you for joining us in this forum. Today we will talk about AI 2.0, Gen AI, enterprise data center, and also corporate cloud. And we would also look at AI server integration with large language model. We invited Intel, AWS, Wang, McKinsey, MIC, Delta, and ASUS experts to share their experience with us. We hope that today's forum will inspire more thoughts and concepts on transformation. Taiwan boasts a strong capability in manufacturing semiconductors. So by combining upstream and downstream manufacturers, we are confident that we will be able to help you in this journey. Corporate AI, edge computing, and edge AI will be the key topics for the future. AI next is the topic of our forum today. We are now in a turning point for the AI era. So we sincerely invite all of you, our partners, to think together what's the next step for AI and how AI can create real value and bring real impact. Lastly, I would like to invite all of you to join COMPUTEX 2025 and witness how technology propels the world forward with AI 2.0. Thank you. Thank you, Chairman Peng. Please stay on the stage. Next, we will invite guests to come onto the stage to take a group photo in the order of their talk in the agenda. First, allow me to invite Mr. Han Strong, Vice President and General Manager of Asia Pacific and Japan Intel. Next, Mr. Robert Wang, Managing Director of AWS Taiwan and Hong Kong. And next, Ms. Emily Hong, Chair and Chief Strategy Officer of Wang Corporation. And last, Ms. Denise Lee, Partner of McKinsey. Welcome. Please look at our photographer in the middle. Thank you. Now, please, can we have a thumbs up? Thank you. Please look at the photographers in the front. Thank you very much. Please return to your seat. Thank you. And Mr. Chang, please come to the podium because you are our first speaker. Thank you. Without further ado, allow me to invite our first keynote speaker. Let us welcome Mr. Chuang, Vice President and General Manager of Asia Pacific and Japan at Intel. And the topic of his talk today is building the future of enterprise AI with open and diverse deployments. Welcome, Mr. Chuang.
Ladies and gentlemen, good morning. I am from Intel. My name is Hans. I'm really privileged to come here to share with you how we can build the future of enterprise AI with open and diverse deployment. There are a lot of industrial reports, and we have seen that most enterprises are investigating or investing in generative AI and how they can adopt their generative AI in their business models. However, the success rate and the enterprises that can create value out of this is less than 1/4. So the implementation of generative AI has some difficulties. Of course, the first one is complexity, because generative AI covers a wide range of applications. All applications will require different models, a huge amount of data, training, and inference and deployments. The models, the algorithms, all have to rely on human resources for further application development. In addition to algorithms, generative AI also will need new hardware. So we will have to incorporate with the existing data centers of enterprises, for example, GPU. So this actually will create new challenges for the existing data centers of enterprises, be it costs or the efficiency and performance. At the same time, how we can apply generative AI in final deployment, this is another challenge, because you will need to train your models, you need to test, monitor, and you need to coordinate different departments to make sure that the models can be applied in real life. Last but not least, the data security and privacy. We know that generative AI rely on a lot of data. Actually, these data are confidential and valuable to enterprises. In the past, we often heard that generative AI is used to run on clouds. That means enterprises will have to upload the data and information to a cloud platform for further applications and use. And that, of course, will create a lot of data security and privacy issues. In the face of the applications, Intel launches a whole package here. We believe that this solution will have to be expandable or scalable. It needs to give enterprises flexibility to quickly adapt to changing workload and other requirements. And of course, the requirement of generative AI evolution. And also, openness is a key here. With openness, your clients will be able to work with you on different hardware or platforms or business software. And then security. All generative AI or enterprise AI will have to run on secure environment. So these securities are multi-layered from top to bottom. All of these are incorporated together. Intel also focuses on chips. We try to incorporate functionalities that ensures security and trust. At the same time, TCO is one of our concerns. So we diverse the AI computing nodes, and we use low-cost or high-performance computing models so that we can lower the total cost for our customers. Our mission is to ensure that enterprises can bring AI everywhere. The deployment of AI relies on a whole approach. So the performance and the power consumption will, of course, mean that we will have different configurations. So that includes AI PC, edge, clouds, and data centers. We know that PCs can address the data centered around people. And of course, as users, we will use PCs to work and to entertain ourselves. So the PC can address the AI's requirement. So be it cloud or offline, we want to ensure the privacy of our users. So this is how we ensure the privacy. So now, edge. So there's IoT, so that focuses on things. So the AI can run its computing on the edge devices, and it also reduces the cost. This will help meet the requirements of different industries. For example, smart factories, smart retail, smart medicine. All these can incorporate AI into their daily operations. Data centers will rely on LLMs or the large-scale usage coming from the users. So now let me walk you through some of the hardware facilities. So from the client, so we heard about AI PC recently. So what is it? AI PC actually relies on CPU, NPU, and CPU and GPU. All of these combined together will be the AI PC that will focus center around the users. So these three components have their own advantages. For example, CPU is used for control and coordinate other processors. For example, digital content creation and audio and images. GPU can be used for text generation or video generation. NPU ensures that we can have a low power consumption for AI operation. For example, in your video conference, you can change the background settings and other low power consuming functions. Now, Intel's Core Ultra can balance different computing loads on these different processing units. And we can ensure that the price-performance ratio is optimal. And with our partners, we can apply to different AI models. For example, under Intel Core Ultra processors, the power consumptions and efficiencies can be delivered to the utmost for our clients. Our partners will be able to work on under the ecosystems they are most familiar with. So as we promote AI PCs, we often heard from the clients, what exactly can AI PC do and what's so different from AI PC and the traditional PCs. So based on their feedback, we recently just launched AI showcases on our websites. There are two of them. The first focused on consumer sides application, and the other is on business applications. For example, on business sides, we have around 300 to 400 applications coming from our more than 200 partners. So we selected around 15. So these could be categories into the categories right here. For example, you can see it right here: security, creativity, or productivity. So this will help enhance our business efficiencies. So there are 6 different categories, 15 applications. So if you would like to know more, please scan the QR code, and you can also visit our website for these AI showcases, and maybe you will be inspired by our AI PC cases. Now, at the edge, a lot of clients have been using AIs. So basically, it's about deep learning, machine learning, or visions. So in real life, all the inferences must be made on the edge so that we can ensure that the AI could be run in a real-time manner. So AI inference must occur at the edge. For example, in some AI or vision or for example, defect detection and QA in manufacturing, or AI computer vision, and there's also medical imaging, multimodal generative AI for medical imaging. And in real life, we are also seeing that the AI inferencing will be a key development in the future. And you will see this in so many different industries, and there's vertical integration in the future. And on the edge, AI will see different demands. These demands will also push the development of these technology further. Now, when it comes to data centers or the cloud-based data centers, we offer 2 solutions. The first is CPU-based, and the other is GPU or AI accelerators. Actually, either of these two could work. It depends on your workloads and your demand for performances and your time latency requirements or the power consumption. These can be catered to your needs. For example, when it comes to CPU, machine learning or deep learning have been applied widely. For example, a virtual desktop or other machine learning analysis or vector rack or traditional deep learning. These actually can be used for image recognition. These are traditional AI-based operations. For example, when it comes to when you need to further advance into the medium or large language models, for example, you have more than 20 billion parameters. For example, if you have more than 20 billion parameters, the model inference, if they are occurring at the same time or called concurrent, be it GPU or AI accelerators, this will help you increase your efficiency. So be it a traditional AI application or the emerging generative AI, these are viable options for data centers. In addition to hardware and diversification of the cost, we also focus on software. We know that AI development is inextricably linked to the software development. So when we are developing generative AI applications, we will go through different stages, for example, data processing or model creation, training, fine-tuning, inference, and deployments. All of these are a continuum. Intel selected the software framework, models, or database, and we provide support so that we can ensure that the open source frameworks can be optimized under Intel's chips. And we also created the open ecosystems to create collaboration. For example, Hugging Face is is an often used AI portal for many developers. There are a lot of models. Intel supports more than 120,000 AI models from Hugging Face, and 220 models actually have been enhanced through our chips. So be it PC, edge, cloud, and other software development, we have created a portfolio for our clients and partners to deploy their AI, be it their AI training models or inference. So when a developer wants to create their own AI application, they will have to go through different stages. For example, they will need to use different frameworks and different models. In the end, they will be able to create an application or solution for the solution. And this, of course, will be used for a long term. Of course, this will be a long run. So how can we shorten the time span? We created the OPEA, which is the Open Platform for Enterprise AI. We have more than 50 partners that provide generative AI-based or enterprise-based solutions. All of these are open source. Our clients, our partners can also use these to create their own POC. So the POC to actual application can be shortened. Like I said, we have more than 50 partners that have been involved in the OPEA. Intel also selected 7 common AI solutions for enterprises. For example, chat questions and answers, and provide reference according to the questions to help train. And there's also code generation, code translation to transfer the existing codes to different operating systems. There's also frequently asked question generation, the FAQ, or content summarization, visual Q&A, and audio Q&A. All of these are common applications for enterprises. These actually can be found on our OPEA. So based on all of these scenarios, Intels have been optimizing all of these on our CPU and our platforms. Our clients can download them and use these applications. So you don't have to worry about coding, be it our AI accelerator or CPU. You don't have to worry about coding. All of these applications can be used as you go, and these are open source. And you can also operate them offline. This, of course, helps to ensure the safety of your information and security of your information. And this, like I said, will shorten the time frame from POC to actual application. Last but not least, Intel would like to use a CPU, GPU, and AI accelerators to promote different combinations from edge to cloud AI. We hope that we will help our clients to deploy their AI applications through Intel's solutions. We can help them achieve that goal. At the same time, we can provide different combinations of our software and hardware to help them accelerate their development. For example, to create the standard AI framework and the AI loading. And there's also CUDA compatible tool. Users can use the codes and then transfer these codes to the open source framework offered by Intel. And also, Intel is actively engaging in different platforms. For example, OPA, like I said, we worked with different partners and different industry players to provide enterprise-based solutions so that we can help reduce the time for use. And there's also chips solution and software solution. AI can help enterprises achieve success. However, the development of AI comes with challenges and uncertainties. Intel wishes to work with our partners to bring AI everywhere in the future, and we hope we can maximize the value of AI. That concludes my presentation. Thank you.
Thank you so much, Mr. Zhang, sharing Intel's AI application. Our next speaker is the Managing Director of AWS Taiwan and Hong Kong, Mr. Robert Wang, and the topic of his talk is Amazon AI without boundaries. Let us give him a round of applause. Welcome, Mr. Wang. Good morning, ladies and gentlemen, distinguished guests, and dear fellow colleagues, esteemed speakers, and new friends, old friends. Good morning. I'm Robert Wang. I'm very honored to participate in the AI Next Forum organized by TCA. I'm happy to share with you our perspective from Amazon on AI. The topic of my talk is Amazon AI without boundaries. Again, I'm Robert Wang. I'm responsible for AWS in Hong Kong and Taiwan. As you know, at the beginning, Amazon is an online bookstore, and then we move on to selling CD and DVD, and then we sell everything. Eventually, Amazon started to sell groceries, online pharmacies, and then web services. We now have our own satellite. Last week, we launched the first series about 20 satellites to space. In the future, we expect to launch more than 3,000 in low orbit satellite area. So when we cross different domains, we used a lot of AI services. We work closely with AI, with Intel, for example. We offer on-demand computing power, and so you can deploy your own AI computing, but you can also use our service. We also launch AI products. For example, last year we launched Nova. We have Nova Micro, Nova Lite, Nova Pro for text. We have Nova Canvas for images. We have Nova Real for videos. These are all different perspectives of Gen AI. Recently, we also launched Nova Sonic, which is the voice-to-text a service. It can talk to you. It can respond based on the emotion that you express. We have new chips. We have Trinium and Inferentia for inferencing. I'm very happy to later listen to Ms. Wang's speech, who is a very important manufacturer of server for us. So we really work closely with businesses here in Taiwan. Here I showcase some of the examples how Amazon is using AI right now. I will try to use real-world use cases to share with you how Amazon is looking at the possible deployments of AI. This is one of our warehouses. Worldwide, we have about 700 sites of 20 different kinds. Some may be warehouses, some may be operational offices, and what we are seeing right now is a warehouse. It's different from traditional warehouse, right? Traditional warehouse would come with different shelves and different numbering and different SKUs. On our shelves, I don't know. I think there must be more than thousands types of merchandise. This can be really troublesome and challenging for retailers and warehouse businesses. So it goes, you can see the racks goes wherever there is space. So if we don't have robots helping us, it's impossible to deliver. For example, we deliver more than 10 million parcels daily. So these are random taking and random shipping is really chaotic. So the AI application in warehousing and robotics is now. We now deploy over 750,000 robots working directly with humans every day. And this is the view from one of our robots. So on the robot, we installed a vision, and it's going around the warehouse interacting with human. Now, robots can combine Gen AI and collaborate with human, talk to human with voice. So it's not like the old stupid robots. Now we are employing smart AI-powered robots. So don't think that robots are simple machines that can move. It's far from that. So this is the AI's view. You can see we are deploying different types of robots. Some are like cleaners, floor cleaners, but some are actually carriers of the racks. We ship with the robots to the center of the logistics, and then different type of robot will take over and then move the cargo to the next phase. So robots are actually helping us solve many problems. For us, the most important thing when it comes to RNA is real use, is real demand. So when we at Amazon develop new products or service, we have a problem or a problem that we want to solve. So the mantra for us in researching is problem solving and also producing real value. Another, I think, key value of Amazon is different a little bit from Taiwanese business. A lot of the proposals in Amazon are made from our own employees. So we adopt a very strong bottom-up approach, and that is a strong source of innovation at Amazon. You can see we also deploy humanoid robots. Why? Because moving the boxes can lead to some work injury. So humanoid robots can prevent a lot of work injuries. In our offices and warehouse, you see these warning signs, and like please do not feed the robots, and careful, butt is crossing. This just tells you how robot is now closely integrating in our employees' daily work. Another great example is Amazon Go. Which is supported by strong AI technology. I think you are familiar with Amazon Go, and in this clip, you can see that customers come in during recess in a football competition. So usually during sports events, between sports event, you have maybe 15 minutes of break. So in such a short time, how can you buy food or drink and get everything you want? If you need to line up for the cashier, you may miss out the important sports event. So Amazon Go is a concept that enable you to comes in and out in a very short time. And this is especially great to be deployed in a sports stadium. You just grab what you want and quickly go back to your seat to follow the next session of the event. You may also be aware of our Amazon Prime. And usually when you shoot for a movie scene, you need different backdrops, right? And if you want to shoot at a very rugged environment like a cliff or a very tall mountain, it's both dangerous and very costly. And here, if you want to shoot with the backdrop of dusk, you need to time the sunset very well. So it takes time and effort to go to the right location. If you missed it, you need to come back the next day. But with Gen AI, inside a shooting studio, the sun will never set. You can take as many runs as you need. So be it deep space, be it coastal area, or simply a beautiful setting sun, Gen AI can help us create the best backdrop and save a lot of cost in video making. Amazon is definitely using drone, but drone is much more complicated than you think. If you need to control each zone one by one controller per drone, then it's possibly not the best solution for business use or for enterprise. But you see, in Amazon, we need to deliver so many parcels a day. So drone cannot be like a toy. So everything needs to be automated. Amazon loves automation because we need to save cost. If we need manual labor all the time, then our service won't be as affordable. So with our solution, we have acquired U.S. Federal Aviation Administration's approval. We now can deliver packages in certain areas in U.S. with our drones. But delivering with zones actually involves a lot of technology and design. For example, during delivery, you need to avoid obstacles. When there is an airplane or a bird coming your way, the drone needs to be equipped with computer vision. So the technology is creating real value. So drones cannot just fly, but also see. Now they need to see to deliver our solution. And the third key point in the delivery service is the best way to drop the package. The computer vision in the drone needs to enable it to see whether the location is safe to drop. So it's not just about flying. Flying is just the first step. This is our Amazon Rufus. So what does Rufus do? If you are a 20-year-old college freshman and you are choosing a gift for this young college freshman, how do you choose a present? Rufus can help you. You can tell him, I am buying a gift for a 20-year-old young boy who loves sport. What do you think is a good gift for him? And Rufus will come up with recommendation. For example, a great pair of sports shoe. Or if you're picking gift for a young 18-year-old girl who loves fashion and makeup, Rufus will come up with a suitable gift, most popular product for a young girl at this age group. So you won't buy the wrong gift. And also, it will also remind you next year when Robert, the young boy, is having a birthday, it will remind you to buy a gift. That's the real value with Rufus. And this is Amazon Nova Reel. In the past, when you need to shoot a commercial, you need to contact a ad company and a media company, and the design process needs to go back and forth between you and the designer. And then sometimes the customer comes up with new demand, and that's very challenging. But now with Amazon Nova Reel, you just need to give it some instruction. You tell it that you want the scene, you want to make sure that the steam from the noodle won't block the view, and so on. You can simply give direction to our Gen AI platform and create such beautiful clip. Another way Nova Reel can help you is filtering the fake reviews online. You know that there are people hiring companies to produce fake reviews online for certain business or merchandise. So manual labor to filter out these fake reviews is quite challenging. That's where AI comes into use. In 2022, our technology blocked 200 million fake reviews in 1 year alone. A little bit about Alexa. In 2014, Alexa was launched. Maybe you have an Alexa at home. Currently, globally, Alexa, we are seeing we have deployed 500 million Alexas around the world. And last May, we launched this clip and showcasing how Alexa is smarter now.
So we can just talk now.
I'm all ears, figuratively speaking.
Ooh, Do you know how to manage my kids' schedules?
I noticed a birthday party conflicts with picking up Grandma at the airport. Want me to book her a ride? Billie Eilish is in town soon.
No way.
I can share when tickets are available in your city.
Yes, please.
Got any spring break ideas?
Somewhere not too far. Only if there's a beach and nice weather.
Santa Barbara is great for everyone. I found a restaurant downtown I think you'd like.
What is Santa Barbara known for?
It has great upscale shops and oceanfront dining.
Can you go whale watching?
Let me stop here. Original Alexa, as you know, it can tell you a joke, share a piece of news with you, tell you the weather, help you shop online. But the new Alexa is more emotional. It can serve as an AI agent for you and your family. What does AI agent mean? AI agent can access different large language models because each model has its own feature, so Alexa can connect them and quickly deliver the answer you want and give you great suggestion. And also, we know that this is a warming event for COMPUTEX. A lot of things I talked about today will be showcased in COMPUTEX, so please visit us in COMPUTEX. So we have invited speakers from the US to share more details of the technology with you. Moving on to robots. This has been a very popular topic here in Taiwan. So just share a little bit with you Amazon's perspective on robots. You saw robots both on Earth and in the moon. And there are a lot of technology involved. A robot shouldn't just be able to move. When you build and deploy, maintain, and manage robots, it takes a lot of effort. In Amazon, we use 750,000 robots per day. How can you make sure that they don't bump into each other? They don't break anything? How do you make sure they can continue to operate and create value? When they send information back to the center, we use OTA to continue to update the robots. Just like your phone, you need to continue to update its operating system. If your phone cannot be connected to the internet, it has no value. It's the same with robots. It will be a stupid robot. It will be a very simple robot. It's like the robotic arms who only does one thing. So if you want to use smarter robots for the future, there are a lot of things you need to look at. We divide the deployment or use of robot into 4 quadrants. In each of these quadrants, there are a few key points. For example, whether a robot or a robot system is a mature solution, that's the first key point. Secondly, we want the robots to be, our system to be differentiated with data-driven innovation. So rule-based robots are not smart enough. Now robots are driven by Gen AI. The third key point or the key area in deploying robots is scale. It's not 1 or 2 robots, it's thousands or tens of thousands of robots. So you need to be able to orchestrate these tens of thousands of robots and also prevent them from being hacked and make sure that they don't bump into each other and they continue to send data back. And the final area was great robot solution is extracting real value, full value. I circle these 3 key phrases in yellow because I think they are the most important when it comes to scale. First, software deployment and management. Think about Alexa. It's like your phone. If we aren't able to update the software well enough, then Alexa will become a useless device to you. A big challenge for robots is disconnection. If you're unable to update the robots correctly, that will become a very big problem. The second key point was scale is fleet monitoring and teleoperation. If you have a fleet of drone or driverless cars, how do you manage them? In Amazon, in San Francisco, we are testing a pilot project, a driverless taxi program. In these taxis, there are no steering wheel or brakes. So how do you manage these fleets? How do you manage them remotely? How do you make sure that they can be safely connected to the internet? And when there's an accident, you can step in immediately. Do you really need to send someone to the scene to manage it? And the final key with scale is multi-tenant device managing at scale. This means that providing a platform to multiple tenant is a key. If you are a traditional hardware manufacturer, you need to think about. I think Ms. Huang will share more insight with us. For example, President Trump wants businesses to manufacture in the U.S., but actually a lot of manufacturing can be done with robots. The Asian model cannot be copied in the U.S. I believe you all agree. So, labor manufacturing is not the future of manufacturing. So, robots will become a challenge for traditional manufacturing. In the future, robots can perform surgery, and so a lot of other tasks can certainly be delivered to them in the future. So we at Amazon want to give everyone a suggestion. Data-driven robotics is really the key for optimization and innovation in the future. From deployment, testing, operating, and maintenance, you need very strong data-driven insight to maintain your competitive edge in AI and robotics. And this is almost the final page of my presentation. This is a quote from Jeff Bezos, our founder. He thinks that the outside world can push you into day two if you want, or can embrace powerful trends quickly. So he really stressed the importance of holding to your core value in day one. In day two, why did he mention day two? Because he said that day two is the time you are going down the slope. So the building in Amazon is named Day One. He wants the Day One mentality to be embraced by everyone. And as you know, you need to embrace the future. Otherwise, you will, and you will have a tailwind. So, drone, low orbit satellites are new products coming up, and it's easy to catch the wind, but it's hard to take off and maintain your altitude. So through this opportunity, we want to show you that we want to work with you, with businesses here in Taiwan. We know Taiwan has very strong capability in manufacturing hardware. Working with us, we will continue to deliver value. Thank you so much, Mr. Wang, to share with you Amazon's boundaryless AI. Our next speaker is Ms. Emily Hong from Wang, who is the chair and the chief strategy officer for Wang. The topic of her talk today is how AI computing power reshapes the global industrial landscape. Welcome.
Ladies and gentlemen, good morning. I'm really thrilled to come here to share with you our observations. Actually, the topic of my presentation is assigned to me by the Taipei Computer Association. So it's titled How AI Computing Power Reshapes Global Industrial Landscape. So most of my presentation will focus on the industry instead of talking about or showing off our products. So since we are here to talk about industries, why don't we start with Taiwan? We all know that Taiwan has a strong and pivotal role in ICT industry. So let me share with you some statistics. So there are more than 25 Taiwanese ODMs and OEMs, and we have manufactured more than 92% of the servers or 75% of the PCs around the world. So with that, Taiwan has also pushed for the development of the industries of the components. And of course, there's the semiconductors. So we have software and hardware vendors in Taiwan. So we have a lot of these hardware and software vendors here as well. And on the right side, you see a lot of the statistics or data for the semiconductor. For example, we have accounted for 60% of the capacity for advanced manufacturing in the world. And our total output value exceeds 78% of the world's total. So in addition to that, we have a strong ecosystem and a strong cluster here in Taiwan. So we have attracted AWS, Intel, NVIDIA, and other CSP as well as industry partners to come here to set up their R&D centers or manufacturing centers. So 92% of the servers, like I said, what does that mean? Right here, it says ODM Direct. It means the IDC. This is a segment from IDC. So when you see this chart, it means the amount or volume. It means server quantity. So this actually is a statistics from 2010 to 2024. So colors represent different brands. The green ones means the emerging direct ODM Direct, and there's the blue and IBM and Novo. So right here, the ODM Direct of Taiwan actually started from 2010. The CSP started to venture into Taiwan, and that was when we started. We started off with 5.7%. Now, in 2024, we accounted for 37% of the world's market share. So, of course, most of them are contributed by these four companies. So, this is the result achieved by me and our esteemed competitors. So I would say that the shares, the market shares have been diluted, and we are seeing some competitions from China. Now, when it comes to servers, we must know some figures. So there's data centers and IT infrastructures CAPEX. Well, in 2024 and 2023, you will see that there is an increase of 56% year-on-year growth. So just a few days ago, you see a lot of the news saying that some companies are halting their business or terminating their production lines. However, last week, you see that the capex coming from these companies are still going strong. So it's around 24 to 25% of growth this year. We know that AI server will account a majority. So the bar right here is the revenue of AI servers. And up here, you see the share of AI servers as opposed to all the servers. So you see 2024 is a turning point because in 2021 we see the growth kicking off. And this year the growth rate will not be as astonishing as before. However, it is still growing. The growth momentum will, of course, bring in a lot of changes into the industry. So from three perspectives, so of course, like I said, I'm focusing on the server industry. I can't focus on all the industries here, so let me just focus on the server industries. So AWS talked about all the amazing applications and everything. I can't imagine showing my videos to you because my videos are actually not that amazing. Well, we have to know that hardware is the key to all that amazing stuff you just showed, right? Because we know that computing power actually drives the technical evolution. So I will start from the technical side and AI booming to focus on the emerging players and the markets that they have created. So they not only created new players, but they also created new markets. So a company like us may be able to provide more services and a larger range of products to these people. We know that models are expanding. Computing power, of course, will increase as well. We don't know if it's the computing power that's driving the models or the model that's driving the computing power. So prior to Transformer, the growth was around 8 folds per 2 years. When Transformer launched, you see this breakthrough. This explosive growth is 256 folds within 2 years. So this is a massive change. Because we need a lot of computing power, be it Intel or other CPU or GPU producers, will have to roll out amazing chips. So maybe we can show some TPU, but I'm not sure our stats are correct, so I'm just going to skip this part. So in order to support the computing power, we will have to focus on the power required by the chips. So for now, it's 1,000 watts. But in the next year or two, it will go up to maybe 2,000 watts. So with this power consumption, there's the heat generated through this process. And then you can imagine the industry of dissipation or thermal industry will start to boom. For example, when we start, we have heat sink, and now we are focusing on cold plate, and now immersion cooling, and some even forecast that in the future, that cooling solutions might be integrated within the IC package. Some companies are already investigating into that field. So the cooling capacity actually grew by 1.2-fold within 2 years, and now it's 2 folds within 2 years. Now, in the future, it will be 3 folds within 2 years with the cooling solutions. So I'm sure that all of our colleagues here know that cooling is important. Cooling is the key here. So within all of the exhibitions, you see cooling solutions. And that is why you are seeing a lot of the companies are seeing their share price surging because of their cooling solutions. So within cold plates or immersion cooling, there are actually a lot of opportunities because you have to know that the technical barriers or the difficulties that we are facing are still there. For example, water leakage. The industry is evolving. So like I said, there's the computing power that will rely on all of these power consumption. So the demand will drive the technological advancement. But I would also say that the technological advancement will also push for demand. So these are complementary to one another. And now I would like to focus on the players. In the last 10 years, we're seeing the development of cloud technologies. So when it comes to key players, it would definitely be AWS, Microsoft Azure, or Oracle, or Google Cloud. All of these are hyperscalers, and they have created a boom in the cloud industry over the last 10 years. So what they were doing is build to rent, and now we are seeing build to self-use. Maybe Amazon will also have its presence in this sector, but you will see Meta, Apple, or Biden's. They are building their own self clusters because they have their own data center demand. So in the AI era, we are seeing new players. Let's just call them new clouds. Maybe some of you are not familiar with this term. There are some large scales, for example, Cohen, Lambda, Nimbuses. Actually, their backgrounds differed. Some of them were involved in crypto or mining or electricity. I will also talk about Lambda as an example later. It was actually a developer in the past. So in the middle, we are seeing an interesting development. This is the emerging sovereign AI. For example, you see YTL from Malaysia and G42 from UAE, and also Tata from India or Sintel from Singapore. So you're seeing all of these coming from around the world. There's more than 20 of them. They're also trying to build up their sovereign clouds or sovereign cloud computing. So there are a lot of them. And there's also one that's catching the attention. That's the model providers. OpenAI, of course, is a company that needs no introduction. There's also Cohere and Anthropic. All of these are model providers. They will also need a lot of computing powers. I think that last year, Microsoft engaged in a lot of computing establishment or building up their computing powers because of their needs. So in the last 10 years, the cloud hyperscalers took up all the market. Now you're seeing all these different players in the market. And in Taiwan, we are also seeing other players venture into this market. For example, Asus or Acer. So like I said, it was like 10 years ago. The opportunities are ample right now. However, opportunities also come with challenges. For example, Sintel is a telecommunications company, and also YTL from Malaysia. It is a big group already. There's construction, there's power, there's also telecommunication as well. So they were not the traditional AI players, but because AI is too appealing, these players are coming into the market. So YTL ventures into the market. Why is it that this is meaningful? It means that AI is powerful. And YTL is actually a utility company, right? And there's also a telecommunication company under its group. So altogether, they can serve as a best data center player, right? And there's also the construction because they built hotels. So data centers are actually something that they can be good at. And now let me move on to some of the examples. Lambda is an interesting one. In 2013, it was established. It used to be a developer that developed a lot of applications. And afterwards, this developer believed that he needs to built his own machine and equipment. So he bought a Supermicro's server and NVIDIA's GPU, and all of these combined together helped him create a company, create a machine. And then he wrote his own applications and algorithms. And the machine that they created actually was quite popular within the developer community. So in 2016, it became a hardware provider. 2 years ago, I went to their company and I saw that they had this Tower AI server, and it was actually quite dazzling. And it was very dashing because it will appeal to the players. But because the developer himself believed that they needed to transform because of the funding requirement and demand, they decided to become an AI cloud provider. They focused on their niche market. They focused on the first segment, which is the developer. According to our conversation, for example, Microsoft and AWS has your own cloud, but your developer has their own cloud because they have a technology themselves, and it's also affordable. They will need a lot of AI computing power, so they have a lot of lever, for example, banks, to help them. So they are trying to scale up. Another example I would like to mention is a regional economic changes. Now here I'm going to showcase a video. It's coming from a Singapore's TV station that's actually investigating into Malaysia. Johor has more than 50 companies that is waiting to be accepted into the data center area. The administrative officer Li Tinghan was interviewed, and he said that the development of Johor's data center actually combines the timing and right collection. The reason why Johor can expand so fast is because in 2019, Singapore rolled out a order to suspend their development. So we have seen a lot of data companies relocating to Johor. That is why you're seeing this development. We have to admit that the complementary between Johor and Singapore is at play here. And because of the success rate we have seen a lot of other players being attracted to our region. So we need to maintain the stability of our policy. With that, we will be able to further develop into the next stage. That is, we can try to focus on some industries that serve the data centers, for example, cooling solutions or fueling systems and manufacturing facilities, because the manufacturing sector can create ample job opportunities. From this interview, you can see that it's actually self-explained. It's self-explanatory. In the past, Asian data centers used to be located in Singapore. So why is it that they are now migrating into Johor? Because Singapore has some limited or some restrictions on power supply. We know that Singapore has their own ideas when it comes to resource allocation. So because of that, a lot of data centers have to relocate. Johor is really adjacent to Singapore. That is why you are seeing this development. So on this slide, you see Singapore, that's Johor, and there's Malaysia. I don't think I should be talking about all this because we have experts from Malaysia. So this is just my humble explanation here. So my company during COVID-19 started to migrate our factories from China to other countries. So our delivery center actually was migrated from Guangzhou, China, or Hong Kong to Johor because data centers were mainly centered in Singapore. We hoped that we can move into other sector. Johor became our best options. So this was during COVID, and last year we have been up and running for more than a year. So we built 2 factories. From Singapore, it's only a 16-minute drive. If you have a smooth custom clearance, it might be 30 to 40 minutes at top. So, like I said, there's the data centers being the data center boom in Johor. Now there are 93 data centers in operations, and 9 of them are still under construction, and more are in application stage. So there are more than 20 data centers in this area. So I think we can talk about YTL because we are partnering with YTL. It's 30-minute drive from our factory. So this is one of the green data center giants in this area. And this is their campus. You'll see that there's power plant, there's water plant, there's also other sorts of facilities. It has a total area of 200 hectares. I think that the Dadu said that we want to ensure that Malaysia could have the latest technology in the world and keep up with the world's trend. In addition to a huge area of land, there are 3 towers there. And then you will see the power plant. It's actually a transformer. So it's a 6-megawatt green data center. And it's now nearly 100 megawatt capacity in its first phase. So it is a leading cloud service provider site. It's also a partner with NVIDIA. Perhaps it is one of the earliest partner of NVIDIA in this area. At the same time, they also provide the sovereign AI computing power for Malaysia in this region. In the case of Wang, we have a lot of CSP as our clients, so we only need to deliver racks to them. But now, we need to build up clusters. So it talks about mega clusters. Actually, we have a lot of cold plates and cases and computer cases or server cases. So a lot of vendors are rack assembly or other operations. However, actually, our clients stream all of these cases together. So we want to create a cluster out of this. This is a huge challenge, but we believe that this is a rare opportunity. We are working with a player that is complementary to our technology. So we hope that we can scale up our scope for our service. Last but not least, made in USA. I think we all know that we are at this point in time, be it the tariffs or the exchange rates, resilience is the key here. You need to be persevere and you need to be resilient. In region, production is a must. We all know that manufacturing in the USA is expensive. So you need to embrace automation so that you can reduce your cost of labor. So we win focused on in-region delivery, and now we have been in operation for 10 years in Mexico, and 70% of our revenue came from America. The data centers are in all over America. And in Czech, we deliver to Central Europe or other parts of Europe. And Johor delivered to Japan, Singapore, India, or Indonesia, as well as Australia. So Johor is our delivery center for Asia. Now, starting from January and February after Trump was elected, we decided in March that we would set up a factory in Texas. Now, in April 1st, the tariff policy was launched. However, we are qualified for tax exemption, fortunately, but the uncertainty coming from the U.S. administration is uncontrollable, so we have to really be careful. Everything is dependent upon the U.S. policies, and of course, you will see that the cost being increased. But this is a must. This is something we have to do. Now, I would like to show you a video of our automation, but I am really ashamed of ours because I just saw AWS video. So please, this is coming from our company, and don't laugh at me, okay? Don't laugh at us.
And digital twins, we elevate manufacturing automation through seamless collaboration and optimized factory planning. ASRS automates material distribution and storage, while AGVs swiftly transport them to the production line, cutting lead time from 2 days to just 2 hours. To optimize production, we deploy PCBA automation solutions, aiming to reduce online labor by 35 to 50% and automating board function testing. Pioneering in-house COBOT design drives our innovation. Our auto system integration seamlessly adapts across multiple product lines, ensuring consistent quality, leveraging robotic arms and fixture systems for unmatched productivity, and propelling us toward 30% assembly automation. Stations powered by multi-server nodes enable simultaneous testing of over 1,000 servers, ensuring scalability and reliability. With digital twins, we redefine manufacturing excellence.
So this is our progress, and it is still underway. And we have seen a lot of machines that help us move. And this is our presentation. Thank you.
Thank you so much, Ms. Hong, for talking about how AI computing can help and shape global industry landscape. Now, please join me and welcome Ms. Denise Lee, partner at McKinsey. The topic of her talk today is global AI ecosystem and the catalyst for transformation. Welcome, Ms. Lee. Good morning, ladies and gentlemen, distinguished guests. I'm very happy and honored to join you today and talk about a very exciting opportunity. I've really learned a lot from the previous speakers, from Emily, Robert, and also our first speaker. And I feel very promising after listening to the talks, and a lot of new faces here today. So can you do me a favor? Close your eyes. I will ask you a question and raise your hand to answer my question. After today's forum, raise your hand if you think AI is a very potential topic or area. Raise your hand if you think that AI is in overhype. Fantastic. Now, please open your eyes. The results I saw, I believe you can guess already. No one raised their hands out in my second question. So I do see that everyone recognized the potential of AI. And next, I will share some of the perspectives from McKinsey on AI. First, to McKinsey, we do see a lot of impact coming from AI in the future. In 2018, we published a report on advanced analytics and AI. After that report, Gen AI and a lot of computing power were developed. So the potential in terms of dollar value continued to grow. The estimation right now is 17 trillion US dollar and above. So what does that represent? In 2024, global GDP is $110 trillion. Last GDP in Taiwan is 0.8 trillion US dollars. So $17 trillion is really high. This comes from value from Gen AI and also from productivity growth. A further dive into possible impact from Gen AI. What this chart shows is how Gen AI can impact different sectors in terms of productivity growth. The highest impact is in the tech industry, but to be specific, the tech here means software industry. The second sector to be impacted the most is retail, followed by banking. And what we will talk about is here advanced electronics and semiconductor. So overall, Gen AI, we believe, can bring very strong productivity growth. It's really worth expecting. And the technology evolves rapidly as well. At the end of last year and all the way until the time that I made this presentation, we already saw many new applications. For example, the Grok 200,000 GPU, the OpenAI O3 upgrade, the DeepSeek cost reduction. So all of these shows that this is a really lively domain and it changes really quick. Let's further think about the implication of these changes. First, on cost. Cost is declining across the board. The cost for training is continue to drop. In terms of training, in terms of influencing, we see the drop comes in very high multiples. On the right-hand side is improvement in capability. I make two more common use cases. One is ME, which is performing really well in the USA Math Olympiad qualifier. The other is the 90% percentile score in the US bar exam. You already see AI improving a lot in those two exams. And where is the value from AI? Emily showed us a chart on different players of AI. I have a similar chart here as well. From right-hand side, semiconductor, its design, its manufacturing, to device manufacturers, to the middle section with data center, including data center system, utility provider, software, server, and apps provider. There are a lot of players in the data center ecosystem. A lot of players need to come together to really build the AI that we're looking for. I have an even more detailed chart to show you later. But this simply shows you how different players need to chip in to really deliver the value of AI. In terms of value chain, a lot of the value chain can already be identified in the software side. And in the hardware side, we are seeing some outliers, including NVIDIA and Wang. There are great players here. And also that's why you see large increase in their valuation. But AI is still evolving. There's still a lot of potential in terms of hardware. Looking at the data centers, for example, we know that due to the huge potential of AI, people continue to invest in data center. These four major companies, for example, the capex they're planning is in together in total more than 300 billion US dollar. What does that mean? It means that the number of data centers across the world will continue to grow by 21% all the way until 2030. And if you look at the white chart, it means the workload increased by AI. And the Gen AI percentage is shown in the blue circles. So this shows us the span of data center driven by AI is immeasurable. So what's the implication? In compute, in power, in cooling, in network and memory, and in many other areas, we see opportunities for innovation. I just list a few. There are a lot more. Take compute, for example, GPU, CPU, ASIC, and maybe in the future, there will be inference specific customer metrics. And also the second category is power on rack level architecture. In terms of the third category, cooling, we talked about air cooling and emerging new cooling system now has piqued a lot of interest. And moving on to the network possibility, we will see growth in transmission to make sure that the transmission intra data centers can produce very good quality. And finally, on memory, high band memory is something that we all know very well. We'll talk each of them in detail. Previous speakers talked about the importance of computing power. I want to also touch upon influence workload. It's a key element. We know by 2030, the influence workload will continue to grow very quickly. We did a survey with CSP, non-CSP, and startups. We see that they continue to think about trade-offs between computing and influence. We see that in enterprises, the percentage of influence continue to go up. They're the main driver for influencing power. And in training, reasoning, influence, and interactive inferences, we are seeing different choices of optimizing for TCO and performance. And we know that emerging GPU is still the key application driver for application, but in ASIC we are seeing customer metrics growing with potential. We are looking also at different hyperscalers, which see the same custom ASICs continue to go up with enterprise spends. If you look back to 2024, all the way until 2030, custom ASICs still has a lot of potential of growth. Next, I want to talk about power. We touched upon the importance of power management. We also agree. We think that power will be the #1 bottleneck in the future. So how do you read this chart? You go from the bottom yellow line to the upper yellow line. That is the expected increase of computing power. So when you go from the bottom up, the first bottleneck is the power constraint. So when the power grow by 10,000 times, we will first hit this bottleneck. It's the first one before before any other challenges. So this is shown or seen already in the U.S. For example, in some markets, primary data center markets like Northern Virginia, Dallas, and Phoenix these are the original key markets of data center. But in the future, Salt Lake City, Denver, Oklahoma, and Kansas are the new potential markets. Why? Because in those areas, you will be able to get access to better power infrastructure. Another information I want to add is that the transformation and distribution system in the U.S. is still improving. The supply chain is seeing the same thing as well. In generator, UPS, or transformer, switchboard, and chillers are seeing longer delay as well. Why? This means that the overall data center and the power infrastructure installment needs efforts, and that means business opportunities. In terms of power, Emily also mentioned that the increase in power density requires better cooling solution. We are seeing more demand in cooling solutions. So here are some numbers to support that. In the data center side, the air and liquid cooling, we are seeing stronger growth, more than 40% higher growth. And behind that, there are a lot of options you can look at, including direct-to-chip for immersion, single phase, full phase. It depends on the density at rack level to choose the best option. And in this area, we are seeing a lot of innovation, and we are seeing a lot of players working together in the ecosystem to come up with new solutions. Some examples here. One of them is EMS to cooling. The second one is chips to cooling. The third one is server to cooling. And the fourth one is powerful cooling. And the last one is cooling to cooling. A lot of players are coming in to create innovation, so a lot of potential here. I also mentioned the importance of network, and so just quickly touch upon that. In terms of higher bandwidth transmission, this is a great insight here. From 2025 to 2029, we are going to see a big change, that is the adoption of 1.6T, and that is something worth paying attention to. So when we combine all these trends together, we see that the ecosystem will be impacted. A lot of the players will be impacted, from compute IT hardware to power support vendors. But I also want to talk about site selection, MEP, data center software, and other services, and also sustainability partners are very important, indispensable as well. So overall, we are seeing a lot of opportunities, and we want all the partners in the ecosystem to work together so we can further drive potential of AI. So if we take a step back, we know that AI has a lot of potential, but we also see that in different businesses, in different enterprise, some adopts AI a lot, some not so much. 90% of the companies said that they need to invest more in analytics. They need to do more in terms of digital transformation. But out of them, only 30% to 25% expected uplift in revenue and cost have been realized. So that's a pain point for a lot of enterprises. They're seeing beautiful pictures in the future, but it seems to be a distant picture, difficult to reach. So is this the same with Gen AI? This is a survey conducted at the end of last year for about 200 big companies in the US. 90% of respondents said that they are starting to use Gen AI, but you can also see that out of them, most of them are in the pilot stage, which means that they're still experimenting it. They haven't seen real value yet. Only the 1% on the right-hand side said that their Gen AI capability is more mature now, and they're using more mature application. Why? We looked into this, and if we look back at cloud adoption, there are some lessons we can learn. If you look back in the cloud adoption, there are a few key points. First, the challenges usually comes from the fact that a lot of these innovation or adoption were IT-led. And this means that the adoption is irrelevant to other business units. So IT was driving very hard, but other business units were not willing to adopt. The second challenge was that even though there were great application and cloud solutions, but the fundamental business process stays the same. So the way people work, their processes, their approval procedures are the same. So the tools are available, but the tools are not generating value. So the tools should be zero-based design so it can be deployed faster and deliver true value. The third challenge we are seeing from the cloud adoption is a lack of talents. And the fourth challenge was change management mentality. A lot of times it was not the problem was the way you work, but it was the problem was with implementation of change. So change management was usually the hurdle for driving new change. So these were the challenges in driving cloud technology. So maybe these challenges are the same with AI adoption. So that means businesses need to adopt new mindset. We further look at the cloud adoption process. We saw that from the left-hand side to the right-hand side, this is the ROI for from edge to cloud. If you only put a little data in cloud or a little workload in cloud, you won't reach a real ROI. So there's a sweet spot here. Only when you use cloud much enough will you reach the sweet spot. And I think the same main goes to AI as well. So each company needs to think about how much workload should be incorporated with AI to generate real value. This slide is about how I am optimistic about AI adoption. We still need to learn. And I talked about how 90% of people are using Gen AI. A lot of businesses are also seeing how AI can or is already delivering good ROI for them. So I have a quick summary here. First, AI do hold immense promise for global economy. I think previous speakers all talked about this, but I want to stress how big the potential can be. And this business opportunity will attract a lot of investments in the future. And in these investments, we will see the need of information in different areas of the ecosystem to deliver real return. That means business opportunities for you. And the third key point is that if you want to do something different as a company, if you want to come up with new business method and productivity growth, there are 5 suggestions McKinsey have for you. These are lessons we get from cloud adoption. I have 3 final questions for you. First, how is your organization enabling the AI ecosystem and capturing the growth opportunity? Second question for you is how is your organization rewiring to reap the productivity benefits? Final question, how is your organization considering change management and mitigating risks in terms of security, privacy, and so on? These are my final points for you. Thank you so much, Ms. Lee. Distinguished guests, ladies and gentlemen, good afternoon. Welcome to the 2025 AI Next Forum. I am your host, Joe. The COMPUTEX preview video we just watched shows that this year's exhibition will be held from May 20th to 23rd for 4 days at Nangang Exhibition Hall 1 and Hall 2. COMPUTEX is ready. We look forward to welcoming partners from around the world to visit, exchange ideas, and create new business opportunities together. Welcome to the AI Next Forum. In the afternoon, we'll focus on the important theme of Enterprise AI Hub, exploring topics such as AI hardware-software integration, edge computing, data center deployment, and the challenges of energy and thermal management. We are honored to have speakers from leading companies to share their experiences and insights on AI technology adoption, infrastructure planning, and real-world industry applications, helping businesses capture the next wave of AI-driven growth. Before we start, allow me to introduce the distinguished guests joining us today. When I name you, please kindly stand up and wave. First, Mr. Simon Wu, co-CEO of ASUS. Welcome. Next, Mr. Steve Lin, Chairman of Auras Technology. Welcome. And next, Mr. Miller Chang, President of Embedded Sector at correction, Mr. Aris Chen, Vice President and General of Delta Power and System BG. Mr. Miller Zhang, President and Embedded Sector of Advantech. Welcome. Thank you. And next, Mr. Chris Hong, Senior Industry Consultant and Director General of MIC. Welcome. And next, our Mr. Zixian Tung, Honorary Chairman of the Taipei Computer Association. Thank you. With us today, we have representatives from various countries' economic and trade offices in Taiwan joining us today. Again, when I introduce you, kindly stand up and wave to our audience. First, Mr. Matthew Branders, Director of Belgium Office Taipei. Welcome, Mr. Branders. Next, Ms. Sarah Liu, Director of Foreign Direct Investment at the State of Virginia Taiwan Office. Welcome, Ms. Liu. We are very honored to have so many distinguished guests joining us today, and thank you for your commitment and dedication to ICT industry. Next, allow me to welcome Mr. Zixian Tung, Honorary Chairman of the Taipei Computer Association, to deliver an opening remark. Welcome. Good afternoon, distinguished guests, ladies and gentlemen. We have so many esteemed guests, and I will not name each and every one of them. The COMPUTEX this year is a really grand event. In the morning, we talked about the AI ecosystem and how we are now at a key era for AI. In the morning, we stress more on the basic structure of our ecology. And in the afternoon, we will focus on the new drivers for AI ecosystem, which is the Enterprise AI Center. The speakers in the afternoon are especially qualified. We have Mr. Ling from Oris. We have VP Chen from Delta. We have co-CEO of ASUS, Samson Hu. And of course, we have Dr. Hong from MIC. And also Mr. Chang from Advantech. I think the most important thing is to recognize that Taiwan is a very important player in building the new AI global ecosystem. Taiwan has long been a very strong partner in the technology sector around the world. 40 years ago, when the PC product was first launched, all the way till the internet, internet era, and then to the era of the AIoT, Taiwan has always been a strong supporter and partner. You and I, we both witnessed Taiwan's participation in the past 4 decades. The important roles businesses here have played. And AI will be our next milestone. In the past, AI was considered a myth or a prophecy or something that would only be realized in a sci-fi movie. But in this afternoon, what we will talk about is how AI can be further realized when we have the infrastructures ready. Now we are moving toward the stage where AI will come into our daily life, and it will gradually become immersive in all technology products. And I think within 10 years, we won't be talking about AI in the future, because, for example, right now we no longer talk about the edge of the internet, right? It is ubiquitous already. But we we'll talk about today in the afternoon is how enterprise can build their own AI center so that any company with an AI center will not be left behind. In the past, business here were often criticized by about focusing too much on products instead of application, focusing too much on manufacturing instead of R&D. But when we move toward the age of AI, we all agree that there are some key driving factors to make AI ubiquitous. First, computing power. Our semiconductor industry, our IC, our system, and our stack manufacturing are one of the top across the world. We play a role in the industry. And second, algorithm. There have been exceptional algorithms that we've seen so far, but this year, we saw that in 2022, ChatGPT was launched. ChatGPT 3.5 ignited a buzz about large language model and AI, but it's just the trigger. From ChatGPT 3.5, we began to see all sorts of AI models around the world, and it gradually becomes a trend. And the next thing that would drive AI, of course, is data. Big data is usually when we talked about big data, it's not just the data of any individual entity. It is the key for application. So computing power, algorithm, and big data, these are the three key drivers to driving AI into real life. And in this afternoon, our first keynote speech is going to be about how a company can actually apply AI and turn AI into a real competitiveness. Our 5 speakers, exceptional speakers today from businesses and from MIC are truly experts, are true experts. So we look forward to their insights, and I wish the forum a great success. Thank you. Chairman Tung, please stay on the stage. We will next invite our speakers and representatives to come onto the stage for a group photo. First, Mr. Samson Hu from ASUS, co-CEO of ASUS. Next, Mr. Steve Ling from Aorus Technology. And next, Mr. Oris Chen, VP and GM of Delta Power and System, and Mr. Miller, President of Embedded Sector at Avantech, and Mr. Hong, Dr. Hong from MIC. Please come onto the stage. Please look at the photographers in the middle. Smile, please. Thumbs up, please. Thank you so much. Dear guests, kindly be seated. Thank you so much for your cooperation. We will invite our first speaker, Dr. Hong, to remain on stage. We will now move on to our first keynote speech by Mr. Dr. Chris Hong, Senior Industry Consultant and Director General at MIC. The topic of his speech is the new AI era, Taiwan's AI hardware and software landscape and future outlook. Welcome, Mr. Hong.
Dear colleagues, ladies and gentlemen, good afternoon. My name is Chris Hong. I am from Market Intelligence and Consulting Institute, MIC, from III. I am very honored to come here to share with you our insights on AI development here in Taiwan. I would like to thank ECA, TCA, because they have been inviting me here every year to talk about AI. And today they asked me to talk about AI, not tariffs. Well, If you want to know more about the tariffs and other U.S. policies, please ask the experts in the audience. Well, if you look back, when we are looking at the development of AI, people are concerned about overinvestment and overhype. So what we have been looking at is that has AI now ventured into the development phase? So what we are seeing right now is AI has been in applications in so many fields. So before I start, I would like to share with you an example from III. So I have superintendents, two vice CEOs. So one of them is really interested in AI. One day he said to me, "Hey, Chris, did you notice something?" He said, "I actually crafted a research paper, and then I spent so little time doing this research." Well, it's not the point here. The point is he wasn't able to sleep at 3 a.m. and he talked to AI for 3 hours and then he finished the whole paper. So you can see that the application of AI and the advancements of CI have now been observed in our daily lives and in our work. So just like what Mr. Tung said, when it comes to AI, there are three components: algorithms, computing power, and data. So these three components are gradually complete. It's not just about LLMs. Some SLMs and open source, be it LLM, SLM, or open source language models, all of them are advancing the AI applications in so many fields. All of them have their own advantages and features. And with LLM and SLM, open source actually allowed them to spread. So according to our observations, there are some issues and gaps that we need to take stock of. So first of all, let's take a look at the ecosystems in the world and the ecosystem of Taiwan. So if we compare them, the first thing we notice is that in the development of AI applications in Taiwan, we have been worried about creativity. So actually in Taiwan, AI servers are massively produced by Taiwan. However, are they used in Taiwan and deployed in Taiwan? That's the thing we need to think about. So when we are seeing the widespread of AI, we need to know whether or not we have the computing power. And the second thing is, when we are developing these models, we have a lot of language sources in traditional Chinese. And we have a lot of data as well. For example, our medical data and data in other industries and sectors. But they have not been properly used, managed. So how do we make the most of these data? These are the things we need to know, and these are the gaps we need to be aware of. And I know that many of you are in this industry, in the industrial sector. So you know that some of your data are confidential. For example, your factory's data, right? So now the algorithms are basically introduced from overseas. We do have our own algorithms, but we still need to work harder. At the same time, it has come to our attention that startups are also venturing into the AI field. But do these startups receive enough support? When we are investing in training, AI training, do these startups receive the support they need for this? Also, how can we deepen our applications? Just like what Chairman Tung said, in the era of AI advancement and AI revolutions, we must be present, and AI cannot be something that we only hold in Taiwan, but we also need to venture into the international arena. Last but not least, talent. All industrial associations or business associations are able to communicate with the general public. And oftentimes we heard about them talking about talent or the talent in ICT or other sectors. So now when we are using AI, where can we secure these talents? So Triple I has been investigating into this. How can we teach people how to use AI in a short time? So Chairman Tom just said to me, you need to start from yourself. You need to know how to use AI. So I think that maybe this is something we need to work together. So how do we utilize AI and cultivate talent in this field? Now, I believe that maybe in this year's COMPUTEX, you might see some of these illustrations. Now, AI is not something you see on the computer. It's not something that you see on the internet. It's actually moving into the physical world. These humanoid robots or robots of other forms actually have seen bundled AI, for example, LLMs or SLMs and control capacities. All of these will create more opportunities in applications, especially business opportunities. So now coming back to the question that people often asked, will AI become a bubble or will there be overhype of AI? Well, of course, as algorithms, computing power, and data continue to advance, AI started to become a major role in our lives. Every day I would say that my daughter is now in a college, and she said, Dad, ChatGPT is my good friend now. So you can guess that she probably used ChatGPT for her papers, reports, and exams. Well, that's her thing. I'm not going to talk about that. But from my point of view, we will see more AI being used in different fields and in the physical world. So I think that Taiwan's supply chain will continue to play a major role in this. It will be in ranging from software, hardware, and semiconductor. Taiwan will have a huge potential to work with international partners. So we talked about Gen AI or generative AI. You are seeing some return on investment of generative AI. So when we look at the hyperscalers, the three hyperscalers are still seeing peaks in their capex, and they are continue to expand their data center investment as well. And the shipment of AI servers are actually increasing as well, as opposed to the general shipment of servers. So you will see that the general servers are around 70 or 60%. In the next 2 to 3 years, the AI servers will continue to grow, and the ratio will grow to more than 30%. And this is just the shipment of servers. And you know that the price of AI servers is actually higher than that of general or common servers. So the revenue or the profit coming from AI servers will continue to grow, of course. Now, AI PC shipment ratio. So from last year to this year, you can see that the ratio has now come to 10%, and we expect that it will grow to 15%, or maybe in the future or in the coming years, it will grow to 50%. So I think that you have seen AI continue to grow. Now, in terms of the servers, data center will utilize AI computing powers. Actually, before the meeting, I've seen some colleagues coming to me and they say that they are working on the edge. I would say, of course, you were on the edge in the past, but now you are no longer on the edge. Why? Because, like I said, once these applications entered into the business environment, manufacturing sector or the financial sector or the other sectors, the AI computing capacity will no longer be constrained to cloud. It will continue to venture into other sectors or maybe edge or end devices. So you have seen a lot of procurement of these capacities. So we talked about AI PC and smartphones. They are also seeing a lot of applications as well.
好，那除此之外，哈，
In addition, from a supply chain point of view, Taiwan has a lot of AI servers, AI PC, and edge computing products. We are seeing a big issue. I think that our speakers will talk about this later as well. Well, that's thermal solutions. So how can we save energy and cool or try to use the liquid cooling solutions? So I think that you are seeing a lot of Taiwanese manufacturers venture into this field. I will not talk about this more. So in terms of semiconductor, Taiwan semiconductor vendors are, of course, important roles in this. And we have seen the integrated packaging capacities, for example, CoWoS from TSMC. This capacity continues to push the development of AI computing power. So I'm not going to talk about tariffs here, but we have to know that tariffs will play a role here. So since AI has a supply chain like this, and in face of the growing demand, where we see a division of labor across the world, well, I have to say, we believe that there has to be some division of labor across the world of some sort. No single country can handle all of these on their own, be it the AI chips or AI capacity. So from the point of view of semiconductor industry, just think about the GPU. There's designed from the United States, manufacturing from Taiwan, and maybe memories from South Korea. So all of these, or even the materials and equipment, are sourced from different parts of the world. So we believe that in the face of the diverse semiconductor demands, we will see division of labor across the world. So coming back to COMPUTEX, in the past few years, we have seen that many international companies are coming to Taiwan for COMPUTEX. I believe that this is also true in this year, because we do believe that international division of labor matters. That is why we are seeing so many international vendors come into COMPUTEX. So we talked about generative AI and how generative AI has helped startups. So you are seeing video-based or coding-based or audio and 3D and other applications. A wide array of startup companies are now venturing into these fields. Now in Taiwan, we also have some system integrators. They are not absent. For example, in our institute, MIC, we are working with the government to support our startups we are helping them to adopt AI applications, and some AI startups are using these new applications for their business models. And I think that Taiwan's companies, there's the different fields, like I said, text or data analysis or video and other brands. And now I'm going to give you some examples. This is something that you probably know, and this is from Either AI. So they use AI models to help them create a smart patient records. And there's also the TechMem robot. So they use the vision capacity to advance the collaborative robots for manufacturing. And there's also Med AI. They are trying to implement their technology in warehousing and productions on the software-defined factories. So these are just some examples, because every time I when I deliver the presentation, there will always be some people coming to me and say that, why don't you list us in your presentation? So I have to say, sorry, there's too many of you, all right? So there's also the financial sector applications from Fubon Bank. You are seeing the AI risk accounts alert. So I will not dwell on this. And there's also one of our companies in Taiwan that uses AI to create animations. From all of these examples, you can see that Taiwan no longer focuses on hardware or manufacturing alone. Just like what Chairman Tung said, we are seeing a lot of software operators or system integrators venturing into AI sectors. And I think that there is something that we need to bring to your attention. Now we are seeing AI in the business fields, manufacturing, financial, or medical sectors. Now there's a big questions. How do we treat the highly confidential data? So I've talked to some of the representatives from other countries here. So we talked to some European think tanks, and we have seen in Europe, data governance is key. For vendors in Taiwan, we have a lot of confidential and classified data. How can we effectively use these data? And we have content trained or generated by generative AI. How do we effectively handle them? So in different sectors and different industries, in specific domains, for example, medical domains, there's the vertical integrations. Generative AI will create data governance issues. So I think that this is what MIC and III have been focusing on. So we are now trying to direct people's attention to AI, to the development of AI. So AI is not just about generative AI. You have to create an AI that is trustworthy. So that's what we have been trying to promote here, be it ethical or human-centered or responsible AI. We think that this will be crucial to the development of AI, and this will, of course, be the top priorities, be it software or hardware vendors. You have to face these issues in the future. Now, in the interest of time, I will have to now conclude my presentation here. So, conclusion. From MIC's point of view, we believe that AI's computing power and applications will drive the growth of the end market of AI and supply chain. So the semiconductor vendors and AI vendors will work together to promote the advancement of AI computing power. So be it algorithms or applications, you have to try to put them into practice. So how can we integrate software, hardware, and create an ecosystem for AI? I think that this will be the top priority in the future. Also, trust will be the key cornerstone for the advancement of AI development. I do believe that Taiwan's industrial supply chain is trustworthy in the global arena, be it delivery or the protection of trade secrets and client data. We can handle them really well. But I think that in the next step, when we are developing our AI, be it our client or our applications, all of these will continue to play a very important role. So in the future, we will continue to work with the vendors in Taiwan. So that concludes my presentation here. Thank you.
Thank you so much, Mr. Han, for giving us a big picture for Taiwan's AI hardware and software landscape. Next, I would like to welcome the president of the embedded sector at Advantech, Mr. Miller Chang, to talk about edge computing and Wise Edge in action. Let us welcome Mr. Chang. Ladies and gentlemen, distinguished guests, good afternoon. I am Miller Chang from Advantech. I'm very honored to be here at the AI Next Forum. This is a very important topic in recent years, edge AI and robotics. Originally, these are two separate technologies. Edge computing combined with AI becomes edge AI and its relevant application. The other topic is an emerging industry, robotics. When these two intersect, they drive a big growth in both industries in terms of the application and innovation of robotics. So that is basically the summary of what I want to talk about today. When we talk about edge AI, I want to first share with you the process from edge computing to edge AI. Many years ago, we were still at the age of edge 1.0. At that stage, each device works in isolation. Each device delivers one task. About 1 to 2 decades ago, AIoT was launched. So that's when we moved into Edge 2.0. We started to see edge to cloud. You send data to the cloud, and the data turns into insight and then feed into the edge device. So the intelligence at this stage stays on the cloud. But in recent years, in the past 2 to 3 years, we are seeing stronger AI. We are starting to see edge computing and edge AI. Each edge AI device is a smart device which can make decision, compute, and execute. These edge devices connect and collaborate with each other. They combine AI and IoT and drives the growth of the AIoT industry. Survey by Market US told us that by 2032, edge AI will reach $143.6 billion of market size. And factories, automotive, and medical healthcare industries are the main market for edge AI. The real business opportunities, however, I believe is much bigger than this. And edge AI can be very quickly introduced into many different industries. Here are some examples. You see robotics, you see scenarios in healthcare, scenarios in manufacturing and smart cities, and other different industries. Let me name a few examples. For example, humanoid robots will reduce tasks, reduce labor costs, and AMR are already applied in warehouse transportation. And the use of drones in agriculture, for example, is very popular. Moving on to healthcare. Now with AI technology, we are able to identify medical images in much better precision. New surgical robots are now being deployed in many hospitals. Smart cities is another popular scenario. For example, self-checkout, urban security, AI-based inspection, and also smart transportation monitoring are all areas where AI and edge AI have been deployed and introduced. So this is not AI next, this is what's happening right now. The second key area that my speech will touch upon is robots. Within Avantech, we have established a unit called Autonomous System and Robotics, short for ASMR. This business unit is to serve the robotics industry. Actually, about 3 decades ago, the automation of manufacturing started to include robotic arms. The main purpose of the robotic arms is to improve productivity and replace certain part of human labor. And then we started to saw AGV, automated guided vehicle, robotic arm, AMR, patrol robots, and also service robots. In warehousing, in retailing, in restaurants, you are starting to see service robots. And the most popular type of robot in recent years is, of course, the humanoid robot. Therefore, this industry, I believe, is developing rapidly, and it's worth our attention. This is from another survey on global market. Also, by 2032, it is expected that this market, robotic markets, will grow by 16% annually. Here we listed several areas of robotics, and the bottom two, the collaborative robots and the humanoid robots, are the ones that will grow the fastest. Both of them will grow at nearly around 30%. But in application and market share, the ones taking the most share out of the top three: AMR, robot arms, and service robots. Again, service robots are often used in warehousing, in service industry. It's installed very quickly. So these numbers tell us that we are now at a turning point where the growth of robotics market will go up rapidly. Therefore, to serve this industry, we established a program called Building Blocks for Robotic Solutions. We see the installation or the deployment of robots in modules. So on your left-hand side, you see first decision making. This is where HAI will play a big role. It represents the brain of the robots. It can connect to voice recognition, text recognition, different types of LLM, and so on. And it will need to combine sensing technology on the right-hand side, like a camera, communication sensors with 5G, and perception sensors, and like LiDAR, and motion controllers, and so on. All those modules need to be combined and utilized so that the robots can move by itself. And more importantly, combining decision-making, sensing, and motion control is the key to ensure that the robot will continue to learn and continue to operate as expected. The building block that we provide are these. First, the edge AI, which is again the brain of the robots. As you can see on the chart, there are many platforms. We work with chip makers. We work with GPU, CPU vendors to provide a variety of platforms. For example, the socket module or the card insert modules for GPU and CPU, or the recent the GPU integrating NPU model. So you don't need to modify the system. You just need to change the CPU, and you will immediately be upgraded to a platform that it enables edge computing. So these platforms can be customized based on specific industry. It can be customized based on your performance requirements. Regular Edge AI board and regular Edge AI server plus software for specific industry. We can come up with customized industry-specific solution. Talking about software, let's come back to software for robotic. That's why we offer this robotic suite for rapid development of robotic applications. There are a few key points in our suite. First, it can support multiple silicon vendors and AI robot SDK, including Intel, NVIDIA, and Qualcomm's SDK. They're all pre-integrated into the solution. Secondly, we offer a graphic user interface so that our client and our users can quickly use these integrated components. And the third feature, which is also the most important one, is our standardized sensor node, which includes the motion sensor, the perception sensors. They are all integrated into our robotics suite. So robotics suite will work with Advantech's Edge AI platform, and together they will enable you to deploy your robots very quickly. This is also an example with TechMan, as Professor Dr. Hong said. TechMan is a famous Taiwanese robot manufacturer. We call this program, we together develop Cobot, collaborative robot. There are a few key technology included in here. Apart from the arms, we also include vision capability. So this is a defect inspection system of a factory. Now with Edge AI, these applications are actually being deployed in factories now. The key pillar of my speech today is Edge AI plus robotic. Our goal is to enable and realize a robotic industry with Edge AI. And there are 4 ways we can do this. First, we will continue at Advantech provide AI and edge computing products so that AI will become a standard component in edge computing. Secondly, we will help to continue integrate more sensor modules. Take the TechMan robot, for example. You include vision and robotic arm. You can also include acoustic capability to the robots to give the robot a better capability. The third way we will help with our partners is on the software side, providing the robotic suite so that your robot system can be realized and deployed much faster. And the last way, the last approach that we can help you with is on safety. All application must meet ISO certification, and that's where we can come in to help. This is my final slide. This ecosystem requires a lot of partners to work together. You can see I put a lot of logos of companies here, from chip makers, sensor makers, wireless modules makers, software developers, and associations, and also systematic developers. They're all listed here. Avantech is also very honored to invite all of you to join us in developing better Edge AI, to make Edge AI a reality. And this concludes my presentation. Sorry, just one more page. I want to share important news with you, because in 2 weeks, COMPUTEX will be held, and Avantech, of course, this time will participate in this very important event. On May 19th, we will hold a forum at the CPC building. And from May 20th to 23rd, we will have exhibition in Nangang Exhibition Center, both Hall 1 and Hall 2. And on May 21st, we will also present at the COMPUTEX Forum. So please come visit us. Thank you. Thank you so much, Mr. Chang, for sharing with the Edge AI and robotics application of Avantech. Next, let us invite Mr. Samson Hu, co-CEO of ASUS. He will talk about AI data center layout and development. Welcome, Mr. Hu.
Ladies and gentlemen, a round of applause for Mr. Hu. Distinguished guests, friends from the media, good afternoon. It is my honor to come here today. As we are seeing ubiquitous AI applications, I think we should also focus on the deployment and development of AI data center. To start with, AI data centers have two important driving forces. I think that we all can agree that AI and LLM have seen explosive growths over the past 2 years, especially after the advent of Transformer in 2018. The numbers of parameters are growing by 256 folds within 2 years, every 2 years. So this is the explosive growth that we are seeing. And it is also a challenge that we are facing. Also, as we are seeing more development of AI technologies, AI applications are also evolving as well. From the early days, we have the perception AI, and now we are seeing AI that help us create texts, code, and images. And in recent years, we are seeing AI with the capacity of reasoning and planning. So that's the agentic AI. So I believe that you have heard Jensen Huang's speech. So they are now focusing on physical AI. So in the future, we can imagine that AI will be able to gain more awareness. And our holy grail of AI application is the AGI. This will be the development that we will go through in the future, be it the LLMs or the AI technology and applications. All of them represent huge computing, and that means AI server and AI data will be growing at the same time. According to Bloomberg's statistics in April, the growth of AI servers will reach more than 300 billions in 2030. So this is, of course, an exciting number, and I do hope that this will come true, because that's the year in 2032. So if we compare training and inference, the inference will have a growing computing capacity of 44% every year. This also echoes the news media's CSP coverage. For example, Microsoft just started to invest more in their inference computing. So people have been talking about DeepSeek. So it's basically so we often jokingly said that it's AI for the poor. So what we are seeing right now is that DeepSeek will allow more businesses and developers to use AI computing in a more affordable way. And this, of course, will create a positive loop. And it will be used in inference application as well. That is why we are seeing an estimate of 44% of CAGR in inference by Bloomberg. In addition to inference, the training computing power will also grow at a CAGR of 18% every year, according to Bloomberg. So I think this is something that we can. Well, this actually also shows that the AI development will go through all of the stages that we talk about. Our holy grail is, of course, the AGI that we talked about. So we will need a lot of computing power. So when DeepSeek was launched, a lot of people were really concerned, but I don't think that this is something we need to worry about. The development of AI data center started from big five CSPs, for example, Google, Microsoft, or Amazon. They focused on pre-training of the LLMs and inference. Now, as LLMs became smarter and more advanced, we are seeing more and more small language models, and they are more domain-specific. So they have also catered to local computing. So on the local end, the data center found by the enterprises are also maturing. The enterprises can also have their data centers. They can use post-trainings. So they can use their specific data sets to fine-tune the models. At the same time, with hybrid structure, they are able to support complicated AI computing that occurs once in a while. So this will allow a more flexible solutions when it comes to cost. So now I'm going to talk about cloud AI data center and local AI data centers. So let's focus on cloud AI center first. According to our years of experiences in building AI data centers, basically, cloud AI data center will have 4 layers of structure. The first is the hardware-based, the infrastructure. Of course, the source of computing power, that's the GP server. And there's also the parallel storage and high-speed internet. And the second thing is GPU support management software. So it will allow thousands of GPU to be operated. So that's the virtualization technologies and resources deployment. This will allow multiple users to use these GPUs in a more flexible manner. And the third layer is the user portal and AI platforms. So AI will, of course, be a key development priority for all industries. So the user interfaces will be the key here. The fourth layer is deployment and services and operation. AI data center demands a high capacity to integrate, deploy, and operate, as well as performance fine-tuning. With that, the clients are able to have a stable, high computing power at their disposal. And I think that this is familiar to you. There are the bottom layer AI infrastructure. The reason why we're seeing rapid AI development is because of the growing computing capacity. So these hardware equipment can process huge amount of data. Just imagine 3 years ago, in a server with 8 GPUs will have 5,000 watts. And now HGX has a power consumption around 10,000 watts to 12,500 watts. Now, the GB300 cluster will have a power consumption of 135,000 watts. So I think that Mr. Ling is probably the happiest man right now because this entails the opportunities for cooling solutions. In terms of hardware, the AI server, GPU has different brands and different structures. Every year, new technologies emerge. So in the AI data centers, there are 4 challenges in operations. The first is GPU generation. In the past, every 2 years you would see a new generation, but now we are seeing this occur at once every year. So our clients are concerned whether or not we can have a cluster that can manage different generations of GPU. That's our first challenge. The second challenge is the GPU technology. In addition to NVIDIA, AMD, Intel, or the CSP's TPU have now entered the competition. So how can we manage different sources of technology within one cluster and allow more options? This is our second challenge. The third challenge is the CPU, the computing architecture of CPU. In addition to Intel and AMD, they have their x86 structure. NVIDIA is also promoting their ARM structure. So this is the third challenge. The last one is the service model. AI will have different workloads. For example, virtual machine, bare metal, or container, or other different computing. So of course, we want to cater to different clients to ensure that the GPU can be maximized in terms of their operation. The infrastructure of AI data center, of course, has a key factor here that's network. That there's east-west compute fabric. So you can see this from the description here, and there's also north-south storage fabric that connects server. And there's also in-band and out-of-band management network. So with all of these connected together, the data center can operate smoothly. This is storage. Every day, data centers will handle a huge amount of data according to data types, data scales, and access frequency, as well as their budgets. The clients will continue different types of storage. Moving on to the second and third layers of software, there's GPU resource management. This is the core to the cloud AI data center. So there's the virtual VMware, and there's also GPU. So like I said, GPU will be expensive because GPU supported computing power will have to work on their budget. So this will be based on their back-end management. In the process of establishment of a cloud AI data center, a professional design, establishment, and operation, if you can coordinate all of these things together, you will be able to succeed. So we will have to help the client to ascertain their workload and provide consultation. Now, on day one, the implementation phase, we need to focus on GPU server and testing, and also the GV management software. All of these must be integrated. Last but not least, day two operation. You will need a professional team to handle the daily operation and monitoring of systems so that your system can achieve service level operation. So the infrastructure of data centers include electricity, cooling, and layout. All of these will take into consideration the possibility of expansion of computing power in the future. So we talk about these cooling solutions. Traditional data center relied on air cooling, so you will need AC or maybe the liquid systems. Now, in the new data center, they have equipped liquid to air or liquid to liquid cooling solutions. So it depends on the electricity capabilities. Overall, the performance fine-tuning of infrastructure is also crucial here. So there are three parts. The first is to look at the clusters. And we have high-pulse impact. I think that you all are familiar with this. And there's also the energy saving management standard, BUE. And there's also the software for machine learning and hardware performance. To accelerate the deployment and management of AI data center, we can use management software. At ASUS, we have two solutions. So you will see the AIDC, the ASUS Infrastructure Deployment Center. This helps our client to automate their deployment and lower their TCO. And the other one is on the right, the ACC, ASUS Control Center. This helps our client to monitor and manage remotely. In Taiwan, ASUS has established our own AI center. Starting from 2011, we have been helping governments and enterprises building their data centers in middle scale or large scale. So there's been 8 of them. Last year, we worked with UV Link. So we were working together to construct Taiwan's largest AI data center. So it is actually located in Chen. And according to the top 500 ranking, this data center ranks 31st. And the Green 500 list, it came at 44th. Now, in the interest of time, I will have to skip some parts of my slides. And now, moving on to local AI data center. Local AI data center focuses on enterprises, government, or other institutions. The hardware, infrastructure, and software are not that complicated as the ones we talked about. The computing power does not need to reach petaflop. So there's there's 1U, 2U, and 4U. And there's also the workstation or the GP10 announced by NVIDIA. So you simply need the workstation level, and it relies on the large language models or small language models. So with fine-tuning model software, it can be used in different application fields. For example, the management of knowledge management of enterprises. Local AI data centers have the capacity of local computing and privacy, security, and domain-specific. In recent years, it has become more and more smart. It has become smarter and smarter and more efficient. And there's also the DeepSeek, R1, Meta, Llama 4, Scout, Microsoft, and everything, as you can see on the slide. Local AI data centers have a huge potential according to different surveys and investigation reports. By the year 2033, we will see 33% of CAGR every year. And small language models and market potentials are also huge. You can take a look at the slides here. Local AI data center hardware solutions have been touched upon, and you will see the parameters as shown here. At our local AI data centers, we have fine-tuning language models. It could be used locally. Last but not least, to conclude, starting from 1995, we are seeing the information everywhere. Generative AI will create knowledge everywhere. It's a paradigm shift. So different sizes of language models will enter our daily life. So we are seeing our development in the AI development. So all of these are the experts in AI. Of course, Jensen Huang said that in the future, we will see humans interact with robots. And Meta's AI scientist, Yana Liken, also said that AI will understand the physical world and have long-lasting memory. And in the future, you will see that AI will continue to advance. Our work and our life will be pushed to new boundaries. So AI data centers will see huge potential and imagination in the future. So that concludes my presentation. Thank you.
Thank you so much, Mr. Hu, from ASUS, for such an insightful presentation. Next, let us invite Mr. Steve Lin, Chairman of ORS Technology. He will be talking about embracing AI infrastructure and advanced thermal solutions. Let us welcome Mr. Lin.
请大家掌声。
Please give Mr. Lin a warm round of applause. Thank you. Thank you, distinguished guests, ladies and gentlemen. Mr. Hu actually delivered half of my speech already, so I can speed up. Today, I, of course, would like to share with you some new developments in thermal solutions. We are seeing a lot of innovations in the past 2 years, from air cooling to liquid cooling, and this change is irreversible. So these are the two main key topics of my speech today. One is AI infrastructure, the other is advanced cooling solution. Usually, you may have tried one of these language models on the chart. Every single one of these models is built based on an infrastructure. It's based on something Taiwan is good at, from semiconductor in the upstream to assembly in downstream. Taiwan is the best place to realize this supply chain. And this chart shows you the growth of AI infrastructure up to 2028. It is estimated that the market will grow to $90 billion by 2028. And this chart is about the rapid increase of demand for thermal solution. From the left-hand side to the right-hand side, you can see the curve going up very quickly. So, yes, there is always demand for a thermal solution here. That's good news for my business, right? And this is talking about power consumption for data center. For data center, key driver, power consumption, thermal solution, and liquid solution. So within an AI infrastructure, there are some key components, GPU, CPU, and as Mr. Hu said, the memory and switches, and also the network infrastructure on the bottom right corner, because we need very fast transmission speed. This is the supply chain from semiconductor to computing, and that requires two key resources. One is energy, the other is water. These resources will continue to play more and more important roles. Liquid cooling means there's liquid water inside, so these resources will become limited in the future. Previous chart showed you how high the power consumption could become. So energy and water resources is really the key. You may see small power plants being built next to data centers in the future. This is about the distribution of power. The cooling system within a rack or a data center requires 93% of power to run the cooling system, which is close to the original power requirement of any IT system. That is why many people think about reducing power consumption in the cooling systems. That is why people started to calculate PUE. The best value for PUE is, of course, 1, which means giving 100% of electricity and 100% is used in computing. But that's, of course, impossible. So ideally, we can reduce the value, keep the value below 1.1 for PUE. But traditional cooling system cannot deliver that. So eventually, in high power systems, people are choosing liquid cooling. Actually, liquid cooling is more cost effective for high power system. It's more expensive to install, but it can save a lot more on your power consumption. And this is the business that I've been working on for the past 30 years, from air cooling on the left-hand side, moving on to liquid cooling on the right-hand side. The best PUE we can get with liquid cooling is 1.6. We cannot go to 1.5 yet. Correction, air cooling, we can only do as low as 1.6, but for liquid cooling, we can reach almost 1.1. So that's 50% of difference. Another example here on costs. For GPU, air cooling with 64 GPUs and 55 kilowatt per rack. 2 rack means 64 pieces, and PUE 1.6 requires the power of 176 kilowatt. And on the right-hand side, you see liquid cooling solution. And if we have 64 pieces with the total power requirement of 121 kilowatt, so it's much lower. The annual cost of power is 100 total kilowatt hour requirement for air cooling is 1.5 million kilowatt hour, but for liquid cooling is only 1 million kilowatt hour. And the actual cost in terms of dollar is between $400,000 per year and $275,000 per year. So your investment will be recovered in 1 to 2 years. So this trend, again, is irreversible. So stop asking me about going back to air cooling. You should be brave and be more bold in investing in liquid cooling. And next, I want to talk about some advanced cooling solutions. From the left-hand side, you all know the IHS, which is the heat spreader on the chip. Based on estimate, it can reach 900 watts. And moving up, we use vapor chamber as the heat spreader, but usually people will go from heat spreader directly to liquid cooling. Vapor chamber is usually not in the chips. Instead, people usually directly go to VLC, direct liquid cooling. And if you move up with the watts, usually the system will need to combine with the chip. Actually, Wei CEO talked about this in the morning. If you are not able to combine it with the chip, you move on to wafer on wafer. If we look forward in the future, the materials perhaps will need to be changed. In the past, we usually use copper. Next, perhaps we will need a mix of copper, graphene, and diamond. And next, we may require to combine the system into a microstructure of the chip. So by 2026, a correction in 2024, for 2 nanometers photolithography, it has already been deployed, our advanced solution. And we believe this is direction to go for cooling system in the future. But there are a lot of challenges in the way because we will need to continue to change the materials we use. This is a comparison between air cooling and liquid cooling. on the right-hand side. With liquid cooling, there are a lot of new materials being introduced. Bottom right corner. I don't know if you have seen this. This is the cold plate being used directly on chip, and also the rack connector, which often leak water because of the quick disconnection. That's why people started to use quick disconnection. And there's a lot of techniques involved. The quality of the water and the design of the components are important. If the water quality is poor, you will start to see leakage. And usually this manifold would be connected with a lot of quick connector to the core plate, and it will enable the circulation. Upper right corner is a CDU, in-roll CDU. Usually, I believe in the future in data center, you will see more of these because they can do 2.4 megawatts. I believe this will be the trend. On the left-hand side, 3D VC and fan are gradually become obsolete in high-power scenarios. There is also a very important power supply unit. I believe the next two speakers will talk about this. The next generation solution will be 300 kilowatt. It's going to be challenging. So we are not talking about adding liquid cooling within the power unit. Because if the total power loss can potentially reach more than 10 kilowatt. Like if we're looking at NVIDIA's watts, we predict this power loss is possible. There can be two solutions. One is integrating with the board, and the other is using the in-roll system. This is launches of new models. For example, for NVL72 and NVL32 have already been discussed. Next year, it will be more challenging. NVL288 and 600 kilowatt for NVL576. Correction. Do you know how terrible that is? This represents the power usage of an entire small town. So, really, I think eventually power generation equals computing capacity. This will become even more relevant in the future. I don't know how much we can support a 600 kilowatt unit like this. This is an in-roll HRU. So it's not liquid to liquid. It is so it can only reach at 100 kilowatt. Bigger ones maybe 200 to 300 kilowatt. But this is also only a short-term solution. Within AI data centers, I believe gradually we will start to see these in-roll CDU, which can do up to 2.4 megawatts or even higher. I believe after 2 years, this will become very common. Right now, in data centers, the big challenge is that the infrastructure cannot be changed rapidly because it requires installation of a water system, and that's a big challenge. How do you deal with the liquid? How do you deal with additional electricity requirement? So I do feel that AI is for big players and big countries. In Taiwan, we need to be very focused with our resources to develop. It's impossible to build 5 or 6 big data centers here in Taiwan. So, but of course, if you are faced with a survival choice, you need to choose between power consumption or computing capacity. This is the solution that we developed at ours. So this is completely different from what I've been working on in the past 30 years. We are now developing different key components for the future requirement. We are now developing different liquid-to-liquid CDU and liquid-to-air. But I think liquid-to-air is only a transition. Eventually, we will all move to liquid-to-liquid. And this is great business opportunities for all business here in Taiwan because each component represents a new business opportunity. So I hope that in this process, we can work with a lot of partners here and we can build a new industry together. And that concludes my presentation. Thank you. Thank you so much, Mr. Steve Ling, for ushering us into a new light of advanced thermal solution. Next, let us welcome Mr. Chen, the Vice President and General Manager of Delta Power and System BG. He will be talking about AI computing challenges, power and thermal solutions. Let us welcome Mr. Chen.
A round of applause for Mr. Chen. Dear colleagues, dear friends, good afternoon. I am the last speaker today. That means we are approaching the end of the session today. So please bear with me for about 20 to 30 minutes. So we've heard about AI ecosystem in the morning, and we talked about AI system in the afternoon. So I would like to take this opportunity to share with you the AI's back end, the power consumption and cooling solutions. So I think that this is a challenging topic for me to deliver. I want to use a simple and easy way to explain to you. I was actually modifying my slides yesterday. The organizer did not receive my latest slides. I really wanted to do this right. That is why I spent so many time honing my presentation slides. So we talked about a lot of issues. Mr. Lin just talked about cooling in his presentation. So I will also talk about our strategy and our solutions as well. These are my agenda topics. So AI computing power, AI data centers. There's the power supply and cooling challenges. Now, the second thing I would like to cover is from grid to chip. How can we provide an end-to-end power supply solution? And the third thing I would like to touch upon is how we can supply power with higher efficiency. So we are also thinking about how power architecture should look like in the new generation, and then I'll talk about cooling technology later. So AI data center has a huge demand for electricity. This is the latest statistics that we're seeing from 2024 last year. Around the world, AI data center consume 261 terawatt hours of electricity. So this is actually a massive number. Now, compared with Taiwan, in 2024, Taiwan used 283 terawatts of electricity last year. So last year, the total power consumption by AI data center around the world is equivalent to the power consumption of Taiwan for a year. So in the future, it will reach 300%, and it will be 500 terawatt hours in 2027. So if we can expand this to other AI data centers in the world, over the past 8 years, the AI data center has consumed 300% of energy from 2022 to 2030. So we are seeing that the demand has been growing, but the supply cannot keep up. So from chip to data center, the electricity actually goes through different systems before they enter the server. So when you stacked the servers and it becomes an AI rack, and then it will become a data center. It actually consumes electricity, right? So let's see. One server might use 2 to 10 kilowatt hours of electricity. And if you stack them together as an IT rack, it will consume 120 kilowatts, 120,000 or kilowatts. So if you put them all together, that's 120 megawatts. That's the current status. In the future, the statistics will look like this. So the chips will consume 2,000 watts, and that's server for 15 kilowatt hours, and AI server rack, 250 kilowatts to 1 megawatt, and AI data center, 1 gigawatt. So if we compare this to household power usage, one data center is equivalent to 100,000 households' power consumption. So if you look at the AI servers, the power roadmap for AI servers, of course, will continue to grow with the power consumption. On the left side, we have the current status, and you can see that it's 120 kilowatt hours. So its voltage is from 2400 VAC to 54 VDC. And this year, we are working on GV300. And next generation, the voltage will be 200 to 800 kilowatt hours. So that's equivalent to, just imagine if you have a refrigerator that consumes so much power, what are we going to do? So in the future, if you have 54 volt, what can we do? So we need to try to lower this. So it needs to go from 54 to 800 volt. And then the rack will be 1.1 gigawatt. So 1.1 gigawatt. So let's compare this with some power plant numbers. I know that we are trying to phase out our nuclear plant here, but this is our nuclear plant 3. This is the generation capacity, 938 megawatt. So that's one nuclear reactor. That's equivalent to 938 AI rack. So if you have 1,000 IT racks, that's equivalent to the power generated from one nuclear generators. That goes to show power consumption will be the key challenge for AI development in the future. So what we are seeing is the hunger for electricity, and there's also many challenges. The first is power source, and the second thing is how can we increase the power consumption? Maybe we can work on power architecture and then power distribution. In addition to the grid, maybe the power distribution within a building is another key issue. Data centers often do not allow crash. So when we talk about 6.9, that we're talking about 6 nines, that means 99.9999%. But can our grid be that stable? I don't think so. That is why we need to have power. We need to have power backup. So when we have such a load capacity, the load will, of course, be connected to the grid, and the power supply quality will be affected as well. And sometimes you might even have blackouts. So That means demand outweighs the supply. So power quality. And then all of these electricity will become heat. How can we dissipate these heat? So I think that these are the things that AI need to address. In order to ensure smooth AI computing, all of these will have to be addressed. Let's now take a look at the infrastructure to power AI chips. From the power plant, power grid, data center, and then to AI chip. This is the power from end to end. On the left-hand side, you have two energy infrastructure. On the right-hand side, these two are the infrastructure of data centers. Our Delta products actually cover all of these four. So I will focus on data centers and AI chips today, and I'm going to talk about what we have done. At an AI data center, from grid to chip, we will see voltage conversion from high to mid to AC, and then it will be distributed across the AI data center. And then there will be power backup and the cooling solution. And the fifth one is IT. We do not have IT solutions, but data center also has to have IT solutions. And then there's data center on the service end. In addition to hyperscaler data center, we also have modular data centers. So we put them into a container. So all you need is water and electricity. This is called modular data center, and it will accelerate the deployment of data centers. And now, from the perspective of power supply, traditional power grid looks like this. At the power grid, within the building, they are AC. Now, please take a look at this small yellow ball here. That's the power entering into the building. We will have a transformer. We will lower the voltage from 220 to 400 volt. And then in the middle, there's the ATS. So it will switch. If the grid is off, it will connect it to the power supply. And then there's the UPS, and then we have IT rack. Our two previous presenters talked about these already. So we will change from AC to 50 DC. So we also heard about BBU, battery backup unit. This is our power backup. Recently, we have this latest technology called PCS, power capacitance shelf. Later on, I'll talk about this. So basically, all of these right here are 50 volts. But when it comes to chips, we have to lower it to 0.6 volt. So once you complete all of these, it's from grid to chip power conversion. So it's 87.6% end-to-end efficiency. So that's 1 megawatt coming into the facility, the building. So 137 kilowatts of electricity is gone. They have evaporated into heat. So you have to remember this. Now, Delta offers a wider range of solutions. So we have the rack power, and it's one unit. It's called 1RU or 1OU, and it's 72 kilowatts. This is a figure that we cannot really put into perspective. 3 years ago, 1U server only consumes 1 kilowatt of power, but now 1 U power will need 72 kilowatt hours of electricity. So you will see that they have different units. There's 12 kilowatts, and there's also 36 kilowatts of three-phase, and also there's the rack of the power capacitance shelf, like I talked about, PCS. So it's going from 50 volts to 0.65 volt. So we talked about PCS. What exactly is PCS? So basically, it looks like this. That's grid, transformer, and UPS, power generators, and AI server rack. So one rack, 120 kilowatt hours. So then, going through all of these, you will see 2 racks right here, the 10 racks right here, and the load is changing rapidly. So you will see that the power is reflected in the grid, and the grid cannot keep up. And what does that mean? So like I said, we have an UPS here. The capacity load is right here. So the volt is unstable. So the UPS will release electricity because it will assume that the power grid is off. And that means the battery of the UPS will be affected. So once the grid is off, you will have to rely on the power generator. Power generator, of course, will rely on motors. And then you will see that the motors will not keep up with this fast changing volts. So the power generators cannot keep up as well. That means you will be at risk of a fire. And then the power grid may also go off. So what can we do? Now, there's the solution. We have an energy tank. It's called the capacitance shelf. So we will use this to adjust the power within the grid. For example, right here, there's the EDPC. That's the line in the middle. That's the average, the mean value. And you will see the fluctuations right here. So when it is up there, we will use this equipment to release that power. So when the power demand is at the bottom, we will let the electricity from the grid to come into right here. So it's called peak shelving. So what we are doing right here is that we can create a stable load, and this will create less impact on the power grid. The power grid will become more stable. So this is the technology that we have been using, and we rely on peak shaving. So we talked about efficiency. So that's the traditional AC distribution. And now the 87.6% is what we talked about. How can we ramp up this number? So that's 10 gigawatts we're talking about. If you convert it to kilowatts of power, kilowatt hours of electricity, that's 10,000 kilowatt hours of electricity every hour. That means a lot of money, right? So what can we do here is that we will reduce the number of power conversion. One conversion means one loss. So from the medium volt, 33 kilowatt, to 0.65 kilowatt, that means a lot of conversion. If we can reduce the number of conversion, the efficiency will be enhanced. So maybe we can think about using DC instead of using AC. So again, follow the path of the ball here. So In the middle, we no longer use AC supply. We will have an independent power rack, 1 megawatt, 1 power rack that supplies 1 megawatt hours of electricity. So it's 800 volt right here. It's direct current. It's no longer alternate current. So this is called CDU, an 800 volt input. You have to have that to work with the system. So going through the power grid to 800 volt DC, so we can increase 1.5%. That's 89.1%. So that's 15 gigawatt. That's a significant saving. But is there a more effective way of doing this? So that's the second route. So all of these blocks have been skipped. So we concentrated them into this solid-state transformer. It's like using the 33 kVc to power electronics to reduce it to 800 volt DC. So that's one goal. 800 VDC and then will be distributed with PDU and PVS. We estimate that this will be 92% of power efficiency. So it's around 4.5% of increase. We think that this will be a huge help for the future power consumption. Now take a look at the power rack. So one power rack requires 1 gigawatt. So there's a lot of challenges and issues that we have to face. So the first thing is three-quarters of the rack is occupied by AI servers. There's no room for power. What can we do here? Why don't we move the power out? So in the future, power will have its own rack. There will be distribution board, and there will be power shelf, BBU, CPS, and there's comprehensive power solution. So it will look like this. AC will turn it into 800 DC, and then it will be supplied to the chips. So it's a comprehensive solution. Now I will not go into detail. If you look at the second route, the 91% route, there will be SST. So, like I said, it will be DC-DC on the right. So it's 6 megawatts. If you have 1 gigawatt, just imagine how many racks you will have. There's redundancy issue. You will have to have 300 racks to supply for 1 gigawatt data center. So power consumption is something we need to work on. So let's now move on to the cooling solutions. So Mr. Lin talked about the chip and IT racks. So we are focusing on the infrastructure level. So from the mid volts, you see every building having the liquid AC. So it will need the fan on the left. So once the liquid enters the equipment, we have the CDU. So there are two solutions. That's liquid to air and liquid to liquid. CDU for liquid to air, that's a water going into the rack. And then the CDU will dissipate the heat within the data center. And then there's liquid to liquid. So the water will go through CDU to the data center. And then the heat will be dissipated externally. That's called liquid to liquid. The PUE will increase significantly. So there are two solutions, liquid to air and liquid to liquid. And on the plate within the servers, and there's cold plates and vapor chambers. So from infrastructure to chips, all the cooling solutions are incorporated. So these are our products. All the racks are higher than me. They are more than 200 centimeters tall. Now in the middle, that's liquid to liquid, 1.5 megawatts. Like I said, one IT rack is 1 gigawatt. So right here, it's not enough. When you think about redundancy, you will probably have to need 2 racks. So this is actually a huge business opportunity. Now, I just talked about the modular data center. So if you want to build up your data center, it's not that complicated. Come to us and buy 1 rack. Everything is all set. Just simply drag it into the field that you want. You have water and electricity. Bam, it's done. So in conclusion, from grid, distribution, power backup, cooling solutions, IT services, and modulars. All of these are the product range of Delta. So allow me to promote our product here. So during COMPUTEX, we will have our booth from May 20th to May 23rd. Please come to our booth. I will be there for all of your questions. Come to me and we can talk about your concerns. So it will be L06178. That's our booth number. And I heard that it's on the 4th floor. I look forward to seeing you in our booth. And we can have more exchanges later. Thank you.
Thank you so much, VP Chen, for such an insightful presentation on power and thermal solution. Today, we have talked about AI edge and robotics and thermal solutions and many different applications. Thank you so much for our keynote speaker and also distinguished guests, our trade office representatives. And this concludes our afternoon session. We look forward to seeing you at COMPUTEX from May 20th to 23rd. On the screen, you can see a QR code for visitor registration. You're very welcome to register in advance. And thank you all for coming. We wish COMPUTEX Taipei 2025 a great success. Please don't forget to return the headset at the entrance before leaving. Have a great day. Thank you.